Ever wondered how complex software systems are broken down into manageable parts? Well, allow me to introduce you to the concept of refinement in software engineering. Refinement is like a master sculptor, meticulously chiseling away at a block of marble, turning an abstract concept into a tangible masterpiece. It's all about taking high-level design or specification and elaborating, expanding or detailing it to produce a more concrete representation. But here's the kicker: while we're breaking down these larger, more abstract components into smaller, more manageable parts, we're also preserving the overall structure and functionality of the system. It's like a balancing act, but one that's crucial to the development of any software. And it's not a one-and-done deal. Refinement is an iterative process occurring at various stages of the software development lifecycle, from requirements analysis all the way to system implementation. Stay tuned as we delve deeper into this fascinating process. Firstly, let's unpack the concept of elaboration. In the context of software engineering, elaboration is a key element of refinement. It's all about adding flesh to the bones of high-level concepts, requirements, or designs. The aim is to provide more detailed and specific information, making the abstract concrete and actionable. Now, you might be wondering, what does this elaboration look like in practice? Well, it could involve adding additional features to a software product, thereby enhancing its functionality. It might mean clarifying requirements, ensuring that everyone on the team is on the same page about what needs to be done. Elaboration can also involve refining interfaces, making them more user-friendly and intuitive. Or it could be about specifying implementation details, giving developers a clear roadmap for turning design into reality. In essence, elaboration is about drilling down into the details, making sure nothing is left to chance. Elaboration, therefore, is a critical aspect of refinement. Now let's explore decomposition, another key aspect of refinement. Imagine you're presented with a colossal jigsaw puzzle. Where do you start? You'd probably break it down into smaller, more manageable sections, right? That's exactly what decomposition is all about in the context of refinement. In software engineering, complex systems or tasks can feel just like that massive puzzle. Decomposition then is the process of breaking these down into smaller, more manageable parts. This not only makes the system easier to understand, but it also makes designing, implementing, and testing individual components a much more streamlined process. This technique aids in identifying and isolating specific functionalities or responsibilities. For instance, a large software application may be decomposed into individual modules, each handling a specific task or function. This separation of duties allows for a more focused and efficient development process. Decomposition thus simplifies the refinement process. It's like tackling that jigsaw puzzle one piece at a time. Next up in our refinement journey is abstraction. Abstraction is like the magician of the software development process. It allows developers to focus on the essential concepts, the magic, while hiding the unnecessary or complicated details, the secret behind the trick. By abstracting away implementation details or low-level operations, developers can create more generalized components. These components can then be reused in various parts of the system, enhancing efficiency and reducing redundancy. Imagine it this way: you don't need to understand how an engine works to drive a car. The engine's functionalities are abstracted away behind the simple interface of the steering wheel and pedals. Similarly, in software engineering, abstraction allows developers to use complex systems or algorithms without needing to understand their intricacies. This process enables them to focus on the bigger picture, the high-level design and functionality of the system. Abstraction hence plays a vital role in refinement. Moving on, let's discuss specification refinement. Specification refinement is a crucial part of the software engineering process. It's like taking a rough sketch of a building and transforming it into a detailed architectural blueprint. This process involves refining and elaborating on high-level requirements to produce more detailed and precise specifications. Now, you might be wondering, what does this refinement involve? Well, it's a multifaceted process. For starters, it may involve adding additional use cases. Use cases describe how a system will behave under different scenarios to accomplish a specific goal. By refining these, we can ensure that the software meets the needs of its users in a variety of situations. Another key aspect of specification refinement is specifying exception conditions. Exception conditions are those situations where the system may not behave as expected. Identifying these conditions ahead of time allows developers to design solutions that handle these exceptions gracefully, thereby improving the robustness of the software. Specification refinement also involves refining data structures. Data structures are the building blocks of any software. They determine how data is stored, organized, and manipulated. By refining these structures, we can optimize the efficiency and performance of the software. Finally, specification refinement may also involve identifying additional constraints. Constraints can be anything from budget limitations to hardware restrictions. By identifying these early on, we can ensure that the software is designed in a way that respects these boundaries, thereby avoiding costly rework or redesign later on. So, why go through all this trouble? Well, the goal of specification refinement is to create a clear, detailed, and precise blueprint of what the software should do and how it should behave. This not only aids in the design and implementation phases of the software development lifecycle, but also helps in testing and validation. It ensures that everyone involved in the project has a clear understanding of what is expected, thereby minimizing the risk of misunderstandings or misinterpretations. Specification refinement, therefore, leads to more accurate and precise software specifications. Now let's delve into design refinement. Design refinement is like a master sculptor chiseling away at a block of marble. The sculptor starts with a basic vision of what they want to create, but as they chip away, they reveal the intricate details that bring the sculpture to life. Similarly, in software engineering, design refinement takes a high-level architectural concept and transforms it into a more detailed and concrete design specification. Let's think of it this way. You're constructing a building. You have a blueprint that outlines the overall structure, but you need more detailed plans for each component. The electrical system, the plumbing, the interior design. Each of these components requires its own set of specifications, and that's where design refinement comes into play. Design refinement involves specifying component interactions. This is similar to how an electrician needs to know how the wiring in one room connects to the wiring in another. When refining software design, we're detailing how different components of the system interact with each other. This might involve defining protocols for data exchange, outlining error handling processes, or even detailing how user inputs will be processed. Design refinement also means refining class hierarchies. In our building analogy, this is like deciding the placement of rooms on each floor. In software, it involves organizing classes and subclasses to ensure code is easy to maintain and understand. Designing algorithms and defining data structures in more detail are also significant aspects of design refinement. This is like choosing the material to use for the walls, or determining the layout of the plumbing system. In software terms, it means writing pseudocode or using UML diagrams to represent processes, and selecting the most efficient data structures for storing and manipulating data. So, you see, design refinement is all about the details. It's about taking a high-level concept and breaking it down into its smallest components, each with its own set of detailed specifications. This process enables software engineers to create systems that are robust and efficient. Systems that can stand up to real-world conditions and perform as expected. Design refinement thus leads to more robust and efficient software designs. Finally, let's discuss implementation refinement. This is the stage where design specifications are transformed into tangible, executable code. It's the culmination of all the earlier refinement processes, where the abstract becomes concrete. At its core, implementation refinement is about writing detailed code. This code must accurately represent the refined design specifications, ensuring the software functions as intended. But it doesn't stop there. It also involves implementing algorithms, those step-by-step procedures that solve specific problems or perform specific tasks within the software. Another critical aspect of implementation refinement is handling error conditions. This means anticipating potential problems and creating solutions for them. It's about building resilience into the software. Performance optimization is also a key focus during this phase. It's about refining the code to ensure the software runs smoothly and efficiently. Lastly, adherence to coding standards is vital. This ensures the code is consistent, readable, and maintainable. Implementation refinement, therefore, is the final step in producing functional software. So, what are the benefits of refinement, you ask? Well, let's delve into this. Refinement, in essence, provides a clearer, more detailed understanding of system requirements, designs, and implementations. It's like having a map that guides you through the intricate labyrinth of software development. This map, detailed through refinement, helps stakeholders, developers, and testers to comprehend the system's behavior, functionality, and constraints more effectively. It's like turning on a light in a dark room, illuminating every nook and cranny, making it easier to navigate. Moreover, refinement enhances the quality and reliability of software. By allowing for a thorough analysis, validation, and verification of system components and specifications, it's like having a safety net. It helps identify and correct errors, inconsistencies, and ambiguities early in the development process, leading to higher quality and more reliable software. In conclusion, refinement is an essential process in software engineering that leads to high-quality, reliable, and efficient software systems.